Okay, hello everybody. We're going to talk about section 8.2 tonight. This is going to be about a topic known as the law of cosines. Now, the law of sines has a few shortcomings because with the law of sines, you have to have a matched pair. You would have to have, say, angle A and side A, or you'd need to have angle B and side B. It's possible, depending on the information that you have, you might be kind of limited and you might not have the angle that you need to have a matched pair. But the good news is there's another way that you can approach solving for the different sides of any triangle, not just right triangles anymore. And that is the law of cosines. There are three different versions of it, depending on which combination of things you know and are trying to find. Now, again, the book is using the Greek letters for the angles. I kind of sort of prefer using capital letters A, B, and C rather than alpha, beta, and gamma, just because I think both the letters are more familiar to people and it makes describing some of the rules a little simpler, like you're just saying, look for the matching letters kind of thing. So without getting too much into the gory details of where this formula comes from, one thing I will point out to you is that this actually has to do, this should look kind of familiar, this final version where it's equal to c squared. That piece of it is essentially the Pythagorean theorem is what it is. And then basically you have this kind of offset to deal with the fact that it's not a right angle. And so, here angle gamma or angle C is not a right angle. So you have kind of this compensation or offset in the formula where you subtract 2 times A times B times the cosine of angle C. And so it's sort of a modification of the Pythagorean theorem. And again, we're not going to get into a lot of the gory details of where this formula came from, but big picture, just something to be aware of is it's no accident. It looks sort of like the Pythagorean theorem because that is it turns out the Pythagorean theorem is like a special case of this situation. If the angle you have is 90 degrees, which fun fact gives you a cosine of 0, which will basically eliminate this whole chunk of the formula, it sort of collapses down into the Pythagorean theorem. But there is the formula, and again, there are 3 versions of it, depending on what you know and what you're trying to find. So let's look at this in action, shall we? And again, let me use the English letters A. This one is capital C. I like to put a little tick mark there because it makes it easier to tell apart my capital C's and lowercase c's. And then that one there would be angle B. So basically what you know, the angle that you have is angle B. So that is going to inform, so angle B right there is 30 degrees. So that's going to inform which version of the law of cosines we will use because we want the one with angle B. Fun fact, if we want the one with angle B, that's going to be equal to the side little b squared. That's going to be a squared plus c squared, the other 2 sides, minus 2, here's a and c, so it's 2ac, times the cosine of angle B, big B. So that would be the version of the law of cosine formula we will use for this situation. Let's put the values that we know into this formula so that we can then try to figure out what the missing side is going to be. So let's see. So we've got b squared. That's going to equal, let's see here. A is 10 squared plus c, which is 12 squared, minus 2 times 10 times 12 times the cosine of 30 degrees. All right, if we get ourselves a calculator, so we're going to have b squared, 10 squared is 100, 12 squared is 144, 2 times 10 times 12 is 240. And let's see, cosine of 30 is roughly 0.8660. So we keep working this out here. We're going to have b squared is equal to, let's find out what this is. We're going to do 100 plus 144 minus 240 times that decimal we just obtained. If you do that, b squared is going to be 36.1539. And then since that's b squared, let us take the square root of that. We only need the positive square root because this is the length of a side here. So you take the square root of that, and when all is said and done, you will end up with b being approximately equal to 6.0128. So now we have a value for side B. Next, our goal would be to solve for one of the other angles. Let's just go ahead and pick angle A, since it is first alphabetically. So if we were to solve for angle A, or if we were to, solve for angle A, we need the formula with big A in it, which is going to be a squared equals b squared plus c squared minus 2bc times cosine of A. So again, a squared, we found that earlier, that's 100. B squared, that's going to be this up here, 36.1539. C squared is 144. Minus 2 times B, which is 6.0128. Times C, which was 12. And then cosine of A. Let's see here. So if we were to add 144 and 36.1539, let's see, that will give us 180.1539. And then let's see, 2 times 6.0128 times 12. That is 144.3075. And then that is times cosine of A. So then what we would want to do is subtract 180.1539 from both sides. So if you do that, that's going to give you negative 80.1539. That's going to equal negative 144.3075 cosine of A. Divide negative 144.3075. And let's see here. So what is, let's see. So we're going to take that and then divide it by that. And that gives you 0.5554. So 0.5554 is approximately equal to cosine of A. So then that means A is going to be the cosine inverse of whatever that decimal is. And if we do that, I'll put the result we get over here. So the cosine inverse, cosine -1 of that decimal is going to be 56.2591 degrees. So we have angle A. And then we're not quite finished because we've got one angle left that we want to find. So let's make a copy of this and then erase some of this stuff here to get a little more room. Okay. No. Okay, so we want to save this. That there. And we can erase all of this business. All right. So we know big A, we know little b, and then the last thing that we need is angle C. Now, the good news is we know that all angles are supposed to add up to 180 degrees. And we happen to have angle B already, which is 30 degrees. So if we do 180 minus 30 minus this angle we just found, 56.2591. And if we subtract all of that, that will then give us angle C. So let's see, 180 minus 30 minus answer we just got, that will give me 93.7409. They don't tell us how much to round to. Usually they will ask for like 1 or 2 decimal places. So for listing out our final answers here, we'll say capital A, angle A is 56.3 degrees. We'll call angle C 93.7 degrees. And then we will call side B 6.0 of whatever units we happen to be in. They don't specify, but there you go. And that is it. That is the answer there. So with the law of cosines, you can use it in one of 2 ways. You can use 2 sides and an angle to solve for a side that you do not know. If you're trying to solve for an angle, that's a little more involved. It involves a lot more algebra, and you need to use the cosine inverse function, which we have seen before. And that will then let you find another one of the angles. And then you don't necessarily have to do that twice, which is the good news, because as you probably noticed, that does take a fair amount of work. But once you have it so that you know 2 of the angles, again, just always remember the fact that all 3 angles add up to 180. So if you do 180 minus the other 2 angles that you then know, you can find the last angle that way. Here is a slightly different problem. So here we have a angle alpha. So alpha in this case is 30 degrees. I like to call that big A. So big A is 30 degrees. Little b is 12 and little c is 24. Because we have angle A, that means we want the version of the formula with angle A in it. So that is going to be this one here where it equals little a. So little a, that's going to be a squared equals b squared plus c squared minus 2bc cosine of angle A. And let's see here. So this is a squared. What is b? That is 12. So that's 12 squared. C is 24 squared minus 2 times the b, which is 12, times the c, which is 24, times the cosine of 30 degrees. And let's see here. So what is this? So a squared equals 144. And what's 24 squared? Is that 576? I think it is. 576 is what it is. Okay. Let's see. Then what? That's also going to be 576, as a matter of fact. Times whatever cosine of 30 is. I think we found that earlier. Yeah, that's the exact same thing. 0.8660. Again. All right, so let's see here. So a squared is going to equal, we're going to do 144 plus 576 minus 576 times the answer we just got, which is 221.1694, roughly. And then like last time, that's a squared. So if you square root that, you can find the value of a. So if you square root that, you will get 14.8718. All right, so that is the approximate value of side A. Then we need to pick one of the angles that we want to solve for next. Maybe we'll just do angle B. Why not? Let's do angle B, shall we? So let's just go ahead and copy the slide right now. All right, so let's make some more room. All right, so we'll save this for later. We are going to want to keep that, but let's go ahead and find angle B. So if it's angle B, we're going to do, let's see here. So we need to start with a little b. So b squared equals a squared plus c squared minus 2ac times the cosine of big B for angle B. All right, we happen to know little b, that's 12 squared. We just found little a, that's 14.8718 squared. Let's see, plus c squared, so plus 24 squared minus 2 times 14.8718 times, what is that, 24 times the cosine of big B, and we don't happen to know big B, so we're just going to kind of have to leave that as is. All right, this is 144. What is that? Before we square rooted it, it was 221.1694. That was 576. And then let's see, what do you get if you do 2 times that thing times 24? You get 713.8 0.8447. Cosine of B. Let's see here. We're going to add those up. 576 plus 221 and some change. So you take that, add 576. That's 797.1694. So 797.1694 minus this thing, 713.8447 cosine of B. You're going to subtract this right here. That's a 4. That's a 7. Okay, so 144 minus 797 and some change. That's going to be negative 653.1694. That's going to equal negative 713.8447 cosine of B, and divide by negative 713.8447. And what is that? So we're going to do that divided by negative that number. That is 0.9150. That is equal to the cosine of big B. So then big B is the cosine inverse of 0.9150, which is going to give me cosine inverse of that angle is 23.7940. And that's an angle, so that is degrees. Okay, so we have angle B. We already had angle A. We found side A earlier. So the only thing that we do not currently know is angle C. Now the good news is finding angle C is a lot less complicated than what we just did. We have finished the hard part of this process. By the way, you should all feel super grateful that you don't have to memorize these thinking formulas. You can just have them written down somewhere and look them up and not have to do this necessarily from memory. And indeed, what's more important to me, I think, is your ability to access and use information rather than just memorize stuff rote. So there you go. So like before, angle C, that's just going to be 180 minus whatever big A is, minus whatever big B is. And when you do that, that will finish off the problem. So 180 minus 30 degrees minus the angle I just found is going to work out to be 126.2060. And that is also in degrees. So last but not least, what we can do is kind of write this a little more concisely and neatly. So let's go ahead and do that. So let's erase some of this stuff here. And typically you are asked to round to 1 or 2 decimal places. You don't want to round until like the very end of the problem. If you round to, you want to keep the values kind of as exact as you possibly can in the middle of doing the problem. Don't round off values until the very end when you're ready to actually declare, behold, this is my answer. You notice I've been sort of very generously using like 4 decimal places when writing these down. Ideally, use the answer button on the calculator that you're using. Or again, if you're doing 4 decimal places, that should be exact enough so that if you're only rounding to like 1 decimal place when you're finished, that should work for you. Let's see here. So basically, let's not erase. So side A is going to be roughly 14.9. Angle B is roughly 23.8 degrees. And then finally, angle C is roughly 126.2 degrees. So usually you only need to provide like 1, maybe 2 decimal places. So anyway, there is the answer to that particular problem. For this example, the thing that's slightly different about it is that you will notice we are given 3 sides from the very beginning. Again, we've already sort of seen this process where you do cosine inverse to solve for an angle that you do not know. So there's not necessarily anything particularly new or different about this one, but the interesting thing about it is that you're starting with nothing but sides, and it's possible to find the angles from that. And maybe what I'll do is just go ahead and make a copy of the slide right now, because I'm going to tell you right now, I'm not going to fit all the work for this ginormous problem on only 1 slide. All right, let's see what we've got going on here. Pick your favorite angle, basically. Why don't we, I don't know, why don't we start with C? Why not? C squared equals A squared plus B squared minus 2AB cosine of C. There you have it. All right, let us put the numbers in where they go and begin our journey finding angle C. So let's see. So side C is 18. This is 18 squared equals 20 squared plus 25 squared minus 2 times A, which is 20, times B, which is 25, cosine of angle C, which we don't happen to know. Let's see. What is 18 squared? That is 324. Okay. That's 324. That I happen to know is 400, 20 squared. 25 squared I happen to know is 625. Let's see here. 2 times 25 is 50. 50 times 20. That should be 1,000, right? 15 times 20, that is 1,000. These are a lot nicer numbers to deal with, quite honestly. Okay, there you go. There's angle C. Or well, not quite, but we're making progress. Let's see here. You add 400 to that, and you get 1,025. Don't get too comfortable though, because we're going to need to subtract that number. Subtract, do 324 minus 1025. What is that? That is negative 701. Right on, there you go. Negative 701 equals negative 1,000 cosine of C. And then what? We're multiplying by negative 1,000. Why don't we divide by negative 1,000? That sounds like a plan to me. And fun fact, I can actually do that in my head. That is 0.701. How about that? That is cosine of C. So if that's 0.701, that means that big C, the angle, will equal the cosine inverse, cosine -1 of 0.701. If you work that out, you will get some angle 45.4927. Okay, there you go. So and that's in degrees. Make sure the calculator you are using is in degree mode when you do these problems. Just a word of advice. Okay, so let us continue the story here. So let's jot that down, what we just got. So angle C was 45.4927 degrees. Okay, we'll save that for later. All right, now we're going to rinse and repeat and do that for one of the other angles. We just did C. How about we do, I don't know, why not B? Why not? Really no wrong answers to that. You just gotta pick one and go with it. You got lots of options. You just gotta make a decision and commit. Unlike my wife choosing a restaurant. Oh my gosh, woman, I'm hungry. I know you like Thai food and Mexican food. There's not a lot riding on that, on the decision. Just pick one. Okay. Let's see. Oh, this actually tells us to find angle alpha. So I'm actually solving for the whole triangle here, but if I were able to read, I would have discovered that we actually wanted to find angle A. But we're going to solve for the whole thing because the homework problems and test questions that you encounter are going to ask you to solve for the whole stinking thing. So by golly, that's what we're going to do, whether we like it or not. Okay, anyway, we'll just cross that out. We're going to solve this like real mathematicians do. All right, so where were we? Let's do B. Why not? B squared equals what? A squared plus C squared minus 2AC times the cosine of B. All right, and again, we happen to know B, that's 25 squared. We know A, which is 20 squared. We know C, which is 18 squared, minus 2 times the A, which is 20, times C, which is 18, times the cosine of B. All right, that's 625. That is 400. That is 324. That is something. What is that? 40 times 18. That is 720 is what that is. Right on. 720. Okay. Let's see. Then what? This is, if you add those up, that is 724. That's 720 cosine of B. That equals 625. We will subtract. All right, what is 625 minus 724? That happens to be negative 99. Right on. Okay, that equals negative 720 cosine of B. And then what are you going to do? You're going to divide by negative 720. Okay, right on. So what is that? Cosine of big B is approximately equal to what, pray tell, is negative 99 divided by negative 720? 0.1375. That's actually what it is exactly. So that equals 0.1375. So then that means big B is, we're still not approximating yet. What am I doing? Anyway, so we're going to do cosine inverse of 0.1375. There you go. And if you do that, you will obtain 82.0968. What was that? 0968. Okay, there we go. And then last but not least, we can find angle A, which is what the problem actually asked for this whole time, but we took a enormous detour to to do that, but that's okay. Like I said, for the problems you will be expected to do, you got to do the whole stinking thing anyway. So we're not going to cut corners. All right, A is what? It is 180 minus 45.4927 minus 82.0968. And angle A is going to be 180 minus that number minus that number there. And you do that and you get 52.4105. There we go. So if you're going to round these off, A is going to be like 52.4 degrees. B, that's going to round up to 82.1 degrees. And then C is going to round off to 45.5 degrees. And there you have it. You have successfully found all three angles of that triangle. So how about that? Okay. So it also turns out that there is yet another way to find the area of a triangle. You've got the old-fashioned formula, 1/2 times the base times the height. We saw another formula involving sine in the previous section. And then here, when we've got the triangle where all we know are the three side lengths, it turns out that there is a formula where you can find the area of a triangle using nothing but the sides. And this formula happens to be known as Heron's formula. Not to be confused with a heron, which is a kind of bird, but this is someone known as Heron who, well, I assume it's somebody Greek. A lot of these people were Greek, but I should actually look up who this Heron is. But anyway, that's neither here nor there. So what you do, you can find the area of any triangle if you do the square root of S times S minus A times S minus B times S minus C. And you're like, well, that's all well and good, but what on earth is S? And I say, aha, well, S is A plus B plus C all divided by 2. That's also known as half the perimeter, also known as the semi-perimeter, because semi happens to mean half. And then because I have way too much free time on my hands and I spend an awful lot of time driving on highways and pass semi trucks quite a bit, I then start wondering why it's called a semi truck, because it's like, is it half a truck? And I'm like, well, so I guess the front part is like the truck and then the trailer is like the other half, I guess. But then the mathematician in me is like, those are not like that is clearly not half of the truck, because the back is clearly bigger than the front. Like, why would you call that half? Maybe like a 2/3 or something. Anyway, I have way too much time to think about these kinds of things. But anyway, you need the semi-perimeter where you just find the perimeter and then divide it by 2. So there you go. So wouldn't you know, there's a very lovely picture of a triangle right there for us, and they tell us the three sides, and our job is to find the area. Now, before we get to the good stuff, before we get to finding the area, we need to take a little side trip and find the semi-perimeter. And let's not use the highlighter. Let's go back to the pen here. Here we go. So what, pray tell, is the semi-perimeter? Well, that is A plus B plus C all divided by 2. So in this case, A is going to be 10, B is going to be 15, and C is going to be 7. We're going to add all those numbers up and divide by 2. Let us see what 10 plus 15 plus 7 adds up to. That is the number 32. So this is 32 divided by 2, also known as 16. All right, so we have found the value of S. It is 16. So now what we're going to do is we're going to say, okay, the area is going to be the square root of S times S minus A times S minus B times S minus C. Again, be grateful you don't have to memorize this formula. You just need to know what it is and how to use it, which really in the grand scheme of things is what's important. So what is this? 16, then what? 16 minus A, which is 10. And then 16 minus B, which is 15. And then 16 minus C, which is 7. So what is that? Well, that's a 16. 16 minus 10 is 6. 16 minus 15 is 1. 16 minus 7 is 9. And then what we need to do is do the square root. Let's figure out what 16 times 6 times 1 times 9 is. That is 864 is what that is. Right on, right on. Let's make that look a little more 4-ish. So then that means that the area, let's see, they don't tell us what to round to. We'll just give them, I don't know, 1 decimal place should be enough. You do the square root of 864. And when you do, you get 29.4. And they don't give us any units, but that's okay. It is 29.4. And there you go. You have successfully found the area of that triangle. So that is Heron's formula. Okay. Let us stop the recording there.